For today's class, we are going to work with an example using inheritance. I'm going back to the example where we're drawing the faces. So just to remind you, to show you what that looked like, we have this application that draws a bunch of faces. Now I want to generalize this a little bit, say that I want to draw different types of shapes. So I want to generalize this to different shapes. So what I've done is I've created a class called shape, and we all have a top left coordinate system, so the x coordinate of the top left and the y coordinate of the top left, so every shape has that. And I'm saying that every shape will have a width and a height. Okay, so those are the four instance variables that I'm saying every single shape object will have. And I want to be able to set these. So set the location, the x and the y, and set the width and the height. And then also I want subclasses to have access to these x and these y coordinates. Okay, so this is a base class that I have created. It's in itself not overly interesting, but every single shape will have this associated with it. So now I can look at this face. So I'm creating now a class called face. And the face class, I'm saying, is a shape, and I'm saying that face extends a shape. So all the information that is associated with a face as a shape, I add onto it. So here's all those constants that I created before that I need to be able to draw a face. And then I already have the x and the y coordinates, so I don't need to add any of that information onto this, so that I can now say that if I want to draw a face on a particularly provides graphics canvas, all I do is I simply draw it. Okay, so I get the width, I get the height, I get the x and the y coordinates on where it's supposed to appear inside of that canvas, and I just draw it. Okay, so this here now becomes a face that I can draw. So it extends a shape class. That means that besides having this draw face method, I also have all of the information that is available from the shape class. So let's take a look at how we're going to use that. Here is that faces, and what I've done is all the information that was for the face has been moved to the face class. So I just have everything that is related to this frame, and that is the number of faces that I want to draw. And I start at the top x and the top y, I compute as I've done before, and the width and the height I compute as I've done before. And I'm drawing along the diagonal. This is what we've done before, using a for loop and doing the appropriate computation. But what I'm doing now is I'm creating an actual instance of the face class. And remember that if it's a face, it is also a if it's a face, then it's also a shape, which means that I can use everything that is in shape and that is in face. So I've created a new face, and then I'm saying, well, take this shape, this face shape, and set the location. And I'm setting the location, and I'm computing the appropriate x coordinate, and I'm computing the appropriate y coordinate. I'm setting the width to the width that I had computed for every single face, and the height. And then I just say to the shape, draw the face, and draw it on the canvas. So that will draw over and over and over again. So this now allows me to draw the face by using both the base class information, the set location, the set width, and the set height, and the information that is extended, the draw face method, that is actually sitting in the face class itself. Okay, so there's an example of an inheritance hierarchy and how to use this. Now I just want to go one step further. This is not the only one that I have to use as I could create another shape. So I've done this. I've created another shape. I've created a car. Okay, so now it's just another drawing. So I've put a bunch of constants up here that will give me a relative location of the different components of a car. And then I add the method, so it extends shape. So it still has the set the position, or set the location, set the width, set the height. That is still available because it is a shape as well. And now I'm saying I'm going to add some additional information, namely how do you draw the car. And again, I call get width in the base class. I call get height from my superclass, get width, get the x coordinates, etc., so that I can do the appropriate drawing. And here, instead of then drawing a face, I want to draw a car. I'm just going to call it shape so that I don't have to change all the other colors, and this is just a new car. Again, remember that a car is also a shape. So this shape has a set location, which both the face and the car inherit, the set width, the set height. I don't have a draw face anymore. So let me comment this out. And for this case, I have now an actual car, not just a generic shape. So I can say draw car, and I want to pass again the canvas in. So notice I just changed those two lines, and it was really nice because they were both a shape, so I could generically treat them both as a shape, and only when it specifically came to the creation of a car and drawing the car, I had to use methods that were particular to the car. So by saving this and compiling all of the changes, let's see what happens when I now run faces. And there it draws cars instead of faces, and the amount of changes I had to make were very, very minimal because they are indeed very similar objects, and I didn't have to cut and paste and duplicate a lot of the work. So here is a notion of using inheritance to create some classes, in particular to create classes that are very similar and that have a lot of common. So the shape of a car and the shape of a face had a lot in common in that they both had that top left corner, and they both have a height and a width of the canvas, or the bounding box that I wanted to draw it in. So I basically took that commonality, put it inside of the shape class, and then both car and face could use it without me having to duplicate this information.